Last thing we're going to take a look at this lesson is composite solids. We already did this with looking at cylinders, spheres, prisms, but now we're going to do it with pyramids. It says find the volume of the composite solid. And this composite solid really has two parts. This has a cube, and it has a square pyramid. So the easiest way for me to visualize this is to find the area of each of those individual pieces and then add them together. The volume of that cube comes from length times width times height. So in this situation, 6 times 6 times 6. The volume of that square pyramid comes from 1/3 base. The base is just a square, 6 by 6 square, base, times height. In this case, my height is 6. So 6 times 6 times 6 plus 1/3 of 6 times 6 times 6, which gets us to a composite volume of 288 cubic meters. If you really wanted to, you could individually find the volume of each piece. This is 216 cubic meters. That square pyramid on the top is 2 cubic meters, and just add those guys together. So again, not much different than what we've done in the past. However, this time we're just putting together different shapes. What I'm going to have you guys do now is try to pause this and do 6, which is basically the same thing, except for now we're looking at a different composite solid. All right, I broke this composite into two different parts, a triangular prism and a triangular pyramid. I found that area of each of those individually. The triangular prism stuff we've done in the past, so I'm not going to talk too much about that. But a triangular pyramid, again, is 1/3 base times height, where my base was 1/2 4 times 8, which is the area of its triangle on the base, times the height, which was 3 feet. The volume of that triangular prism was 80 cubic feet. The volume of the triangular pyramid was 16 cubic feet. Add those guys together to get to 96 cubic feet. And that is not much new for you guys, but again, there's practicing and looking at composite solids and how we can use what we know about different three-dimensional shapes to find the volume of a composite solid.